Vex, who make robotics. They make physical robotics. They also, sort of last year, launched a VR robotics sort of playground environment, which is web-based, which takes away a lot of the problems with parts, charging batteries, and it's just quite good for classroom use when you've got 16, 17, 18 pupils in a classroom, rather than have robots racing around. So we do have some physical robots. We do have the, by this company here, Electrofreaks. We have got the, let me try and find the link quickly, car kits. So we've got these here, the Cutbots, with battery packs, and we've got these that come with obviously ultrasonic sensors, line detection underneath, obviously the sensors that are on the microbit themselves, the accelerometer measuring force in the X, Y and Z axes, obviously it's buttons, tilt sensors. So there's lots of different sensors we can use to control the robot. These do also have radio, so you can do some kind of hive type things in terms of proximity detection with the radio, in terms of getting them to move towards another microbit or communicating with each other. We do have some remote controls as well that go with these. So they're good fun, and also I've bought some AI lenses that go with this. So they sit at the top. I'll give you one to play with. So if you do want to do some physical robotics, the AI lens, you can do, it's got some built-in recognition. With the pack comes some cards like road signs, arrows, pictures of kind of different objects which it will recognize. You can use, and you can also train it with the AI lens. So you can train it on gestures and certain things. Obviously it's limited in terms of what it can do in terms of hardware, but it has some capacity to do some machine learning to recognize physical things in the environment. So all of this is on a wiki, which I will post in the email, which gives you some code that you can copy across to a microbit and try it out and have a play with it. And that's the point at which we'll ask students to kind of have a play with it and perhaps set some challenges. Now back to Vex. So I've set up some classes here. So what we'll do when we come to it is copy the direct link. This will then, when they click on that link, it'll take them to this web page, which is Vex VR, and obviously it's got the class code here. What that does is enable them to select essentially the basic and the premium playground. So there's a lot here. These are the playground. So this is like the virtual space. There's hex bugs, which you may remember, the little vibrating bugs somewhere on here. And there's also lots of different maps and things. Now, the idea is they pick one of these, like Castle Crasher, for example. And then there's some activities they can do with that. And you might want to show those separately. So I've got it open here in another tab. So VX activities here. So there's lots of kind of worksheets which you could print, perhaps. So if I go to try and find some challenge solutions and everything. Now what I'm trying to do is find I don't want the answers. It makes you go back to here. Here it is, sorry. Always scroll down. So you pick one of these and it matches, it'll tell you which playground it's to do with. So, I don't know, let's have a look. There's lots to choose from. So this one here uses, Castle Crash Course. Some that require the drawing tool of the robot. There's different robots, so there's this version here, and then there's this version. There's sort of 3 different virtual robots to choose from. But you can see there's lots to choose from. I was just trying to find Castle Crasher that I've used for outreach and open days. And some of these are the premium ones. Here we are, Castle Crasher, that's what I was looking for. So it gives it to you as a Google Doc. Of course, you can just put that into OneNote or print them off, one-sided or two. And there's obviously challenges 1, 2, and 3. It tells them what playground to open. and what they have to do, which you can run as a group activity all at once, or get them to try and complete it and take a screenshot and put it in a OneNote as evidence to see what they've done. But essentially, it looks like this. Lots and lots of activity sheets that you can do this way, or come up with your own activities within the virtual environment. So they get this playground window like this. They can change the screen, they can zoom in and out, and then they've got blocks here in which they can put it together, and they can, if they want, look at the code view, look at the Python type view in terms of, you know, seeing how it puts together. So for example, if I go drive forward for 200, which is one of the squares. So most of the playgrounds, a lot of the playgrounds have kind of like a grid system. So that is defined by 200 millimeters, as it were. You can see how that looks in Python code. And if they want, they can, you know, copy and paste and work within Python, or switch between the blocks. And obviously you've got sensing blocks and putting that together, as you'd expect, to perform more complex behavior and movement, really, and sensing. So all there. The project guide sheets, as you saw, are there, which you might find easier to print. So they've got it beside them, and then they're doing it on screen on their surfaces. And we'll have, you know, maybe 2-3 weeks, so not a lot of time, just for to play around with this, to complete activities, do some competitions perhaps in terms of, you know, who can get the most castle crashed over like this, you know, or, you know, or whatever you fancy doing. And like I said, you can then use the physical robots perhaps as well, if you wish to do some physical robotics which have the sensors, and we can work out how we sort that out. Any questions, let me know.